In this video, we're going to look at a synoptic style question that involves both mechanics and also thermal physics. So pause the video now and try all parts of this question. Part A, describe the energy changes that take place to the lead pellets following one inversion of the tube. So after the tube is inverted and turned upside down, the pellets will be up here, and then obviously they're going to fall down this way. So at the top of the tube, what do they have? The pellets have gravitational potential. This changes to kinetic. As they fall, or you could say it moves into the kinetic store. And then when the pellets get to the bottom, they obviously hit the base of the tube. And what happens then? This kinetic energy turns into heat, or it moves into the thermal store, right? And the pellets get heated up. Now, it might not be obvious that you have to put the second part to get the mark, but if it's not obvious, it should be after you've read through the remaining parts of the question. So when you've got to part D and you've seen the whole thing is about temperature rise, it should be fairly obvious that there's something missing from here if all you wrote was this first bit. Part B says, use the information here to calculate the specific heat capacity of the lead. So the first thing I always do is I think, well, my equation for specific heat capacity, MC delta T. So what do I need to work out here? I need to know the mass, the heat capacity, temperature change, and the energy going in. So what is the energy going in? Well, the energy going in is obviously the GPE that the pellet has fallen through, that's obviously then turned into KE. But it then turns into heat or thermal energy. So our GP is mgh. That obviously equals the energy going in. So we can say that mgh over delta T is equal to the heat capacity. And then I think we have all of, oh no, we don't have almost all of the information. We've got to be really careful here. We've been given the number of inversions. So let's just check everything's right. The masses cancel, so actually it doesn't really matter what the mass is. G is obviously a constant. Height, we know what the height is. The change in temperature is given to us here. But importantly, we've got 50 inversions, so we've got 50 lots of this gravitational potential energy. So now we can plug in the remaining numbers to get our heat capacity, which is equal to 130 joules per kilogram per per Kelvin. State two assumptions you've made in your calculation for the heat capacity. Well, we've assumed that there is no energy loss to the tube. So that's through conduction. And we are also assuming, this one's a bit harder to get, but we're assuming that all of the lead, or all of the pellets, fall the same height. In other words, they have the same GPE. Part D, state and explain the change, if any, you would expect to see in the temperature rise if the mass of the lead pellets is doubled. So it's useful to refer back to our equation for temperature rise. The change in temperature is mgh over mc, and obviously times by the number of inversions as well. So what did we say about the masses? The masses cancel. Or I should say the mass cancels. So the change in temperature remains the same.